we can make mark and sweep a little, I wouldn't say more efficient, but spread the work over time. What does that mean? Right now, the way the theoretical mark and sweep works is that we go and we wait until you ask for new memory and none exist. And then you go and you say, okay, let's start the algorithm, mark them all as garbage, and then go and say, okay, they're not garbage, and go through all the levels. Now, notice that we can actually go and play a bit with that notion. Why? How? What we would do is the following. Before we start with step one, okay, we are at some point in time that, just erase all our little pointers here. Okay, now we could go and say, okay, anytime that you allocate a memory, mark it as garbage. Now that's the thought. What I want to say is that when I go and I say, let's say garbage is 0, let's just say garbage is 0. So when I went and I allocated this 13, I'm going to immediately mark it with a 0. It's garbage. Okay, so notice that all these guys are going to be zeros. This guy right here is going to be not a 0. Later I'll tell you why, right? All these guys are going to be allocated as zeros. This guy right here is also not going to be a 0. And all these guys are going to be zeros. Why is that? Because anytime I allocated something, I marked it as garbage. Now, when I run out of memory, what I say is the following. What I say is, okay, step number 1 of marking everything as garbage, I'm not going to do. I'm not going to do. So notice that some of these guys are garbage, and some of these guys are not garbage. Now, there's 2 groups here going on. There are those that are marked not garbage, like this guy right here and this guy right here. They're marked not garbage, even though they're empty. And then there's those that are really not garbage. Of all of those that are marked garbage, some are garbage and some are not. Now, what I would do is the following. Notice what happens. I would start with step 2 of the mark and sweep. What I would do is say, okay, let's go from the live set into the runtime stack and mark all those that are not garbage as not garbage, like we did last time. That's step 2. So we mark this guy and this guy and this guy and that guy, right? Yeah. All these guys, they're all not garbage. So let's mark them as not garbage and mark them as not garbage. Now notice what happened. Notice what happened. Now we have moved part of we split the, should we say, garbage set into real garbage and not real garbage. Now, I'm not saying live because some of these guys are not alive. Some of these guys are, in a sense, empty, right? But we look at the one group, right? So we say, okay, all of these guys are, let's call them alive. Now, notice that I'm wasting memory. These 2 empty guys over here, which are marked as alive, I am wasting them. It's true. But they will be reclaimed at the next step. So up to this step, in a sense, 0 was garbage, right? 0 was garbage. And 1 was live. Now what I'm going to do is I'm going to switch. And I'm going to say, okay, I'm going to first, before I switch, I'm going to first collect all my zeros into my new free list like I did before, right? And I'm going to go and say the following. Anybody I touch is going to be marked as garbage, but I'm going to switch between the definition of garbage and the definition of live. So now, when I go and I reallocate memory, let's say I allocated, notice all these guys, I can allocate them again, right? All these garbage was all freed up. I can reallocate them if I want, right? They're all freed up. And now I have my memory of live and not live guys. Now, what I'm going to do is anytime I allocate somebody, let's say I put a 13 here, right? So I'm going to mark him as garbage. And suppose I go and I put a 17 right there, I'm going to mark him as garbage. Notice I switched the definition of garbage and not garbage. Now, suppose I go and I put a hello and H over here, switch them to garbage, etc. And as I add more values, right? More and more guys are becoming garbage, okay? And let's say I allocated this guy right here, and I gave him a W, so he became garbage. Okay, he's already garbage, whatever it is, and I can go on and on and on. Notice what happens is that now the opposite happens when we actually go and we have to decide where to to reallocate memory. Then it's the other way around. Most memory blocks are already marked as a one, including the empty blocks from last time. These guys right here, including the empty guys from last time. And now again, I do step two. I actually go and I start from my live set and move into the heap and mark all the live guys with a zero, because a zero is a non-garbage guy. So if we assume that before that all these guys are garbage, I'm just again marking off garbage. If I assume that all these guys are garbage, whatever, right? So I'm going to start at the one time at the heap and mark these guys with a zero, because that's the definition of garbage right now. The next time around, right? And that way, the way I can go I flip between garbage and not garbage. So I actually go and I save myself the first round of the mark and sweep. Now the cost of that is that I'm going in empty spots are not going to be marked as garbage. They actually be marked as not garbage, but they will be reclaimed at the next cycle, because the next cycle, when the one is the definition of garbage and zero means not garbage, these guys will be marked with a one, right? And again, there will be all those that did not allocate and they are marked with a zero. That's okay, but the next cycle will be reclaimed. Why am I doing this? I am doing this to save the time during the actual allocation. Notice this doesn't save actual time, because what is the difference if I mark somebody as garbage when I allocate them, or I mark him as garbage when I do the first step of the mark and sweep? It's the same marking as garbage. The difference is that I'm doing it at non-critical times, which means when I am trying to do something and suddenly there's no memory and the whole system freezes and it's doing garbage collection, that's a critical point in time. I'm not interested in having all these things run at a critical point in time. I rather move a whole bunch of operations to different times when the code is running in order to actually get the critical time zone when I actually have to run the actual mark and sweep, because I ran out of memory, to be as short as possible. So I paid by having empty slots marked as non-garbage, which means they're being wasted a cycle, but they're not wasted forever, because they were reclaimed by the next cycle.